Good morning, doctor. I'm Wong Jiajing, and today I'm going to present about my IoT mini project, which is IoT-based predictive maintenance system using WOKWI and THINGSPEAK. So for my system, my focus is predictive maintenance using IoT, and the focus is on SMT line and in the sector of healthcare and life sciences. So for me, predictive maintenance is in an SMT line uses IoT-enabled sensors and real-time analytics. And then the goal is to anticipate equipment failures, ensuring efficient production and minimizing downtime and costs. So moving on, this is the objective of my mini project. So the first one is my system aim to minimize unplanned downtime, and secondly, it aims to enhance operational efficiency besides improving quality and also yield. So moving further, this is the circuit design part. As you can see, I am using 3 sensors, which is the first one is ultrasonic sensor. This ensures AOI and also SPI calibration. AOI is automated optical inspection and SPI is solder-based inspection in my SMT line. So this can preventing inspection errors. The next input is LDR sensor, which maintains consistent AOI lighting, avoiding misclassification or defects. So the third one is DHD sensor, which will control humidity and temperature. This is to reduce PCB and soldering issues. So for the microcontroller, I'm using PiPicoW because it has the Wi-Fi connection for me to connect to THINGSPEAK. So THINGSPEAK will be used to collect my data and store it. So for the output part is buzzer and LED alerts. I'm using buzzer and LED alerts to provide me immediate action to prevent defective production. So in terms of data analysis part, I'm using THINGSPEAK, which will allow me to have early fault detection for proactive maintenance and also managed analysis, which will identify trends and predict failures for early alerts. So moving further, now we are in the data transmission and visualization part. So after running the program, this is the result shown on the serial monitor. You will first connect to the Wi-Fi, then it will show each value of the parameter. So the first one is LDR, the second one is temperature, third one humidity and distance. So as you can see here, I have preset threshold value for each of the parameters. This one I preset according to industrial standard, which I set for my SMT production line. So this one, it shows the current response is sending to, and then this one shows that the data already sent to THINGSPEAK. So moving further, this is the dashboard result of my THINGSPEAK channel. So as you can see here, I have 4 fields, which is humidity, temperature, light intensity, and also distance. So all are shown in a line graph for easy interpretation. So moving further, now is the justification for data analysis. This is the 4 justify of my approach for magnet analysis. So the first one, I got calculate average value, which can monitor long-term stability, detect gradual changes, and prevent system degradation. And next part is I got measure the exceeding threshold frequency. This is to identify critical spikes, trigger alerts, and prevent defects. So moving on, I also got consider the 20% below threshold. So this acts as an early warning, enabling preventive maintenance before failure. And lastly, I got list out all the values for those exceeding threshold and also for those values which lies in the 20% below threshold, as it tracks trends, identify root cause, and support predictive AI models, in which is the further improvement of this system. So moving on, this is the magnet analysis part. For the first one is humidity. As you can see, humidity, it got measures the average value and then got projects those that exceeding the threshold, which I set at 60%, and also the number of readings within the 20% below threshold. So as you can see, all the values are listed down. So similarly to distance for the threshold I set is 60 cm, and then for the temperature threshold is 25 degrees Celsius. Similarly, they will project all the result as well. So for the lights, I set the threshold at 4500. So now is the demo time. I'll demo my system together with the data analysis part. So this one is my coding for my system. And then this one is the API key together with the URL. So now I'm running the system. So first you'll show connecting to Wi-Fi. Then once connected, you'll project each of the value of my parameters. So as you can see here, all value is within the threshold. So there won't be any LED alerts or the buzzer. Okay, now the data is already sent to THINGSPEAK. So now I'll try to trigger the alarm. I set greater than my preset value of 16 cm. Okay, so now humidity is under threshold, temperature also, lux also. However, distance exceed, so it will beep and then there's an LED alert. So now waiting for the data to be sent to THINGSPEAK. Okay, so now I'll try to, for all to exceed the threshold. Only the lux is within threshold. So now the simulation runs. And then as you can hear, now this one exceed, temperature also exceed, and then lux is within, distance also exceed. So for this one, I set the buzzer and also LED to be triggered each time after this one, the result projects. So it's in the sequence as well. So now the data sent to THINGSPEAK and we'll move to THINGSPEAK. So as we can see here is the result that I triggered just now. So it's real time in here. That's all for the channel setting and also the dashboard of my result for THINGSPEAK. And now moving on to the MATLAB analysis. So here is the MATLAB analysis, and because due to time constraints, so I use 600 to let us have a watch of this one, the output. Okay, so now I save and run to see the output. Save and run. So MATLAB code runs successfully. And as we can see here, it got projects the average value, the number of readings exceeding the threshold, 3, and then this is the instance in which the value exceed. And also for the number of reading within 20% below threshold, which is this one, and then it got list out all the value. This one is for the predictive maintenance part, as the operator can identify that at any instance like this one, the machine is quite oftenly near to the threshold, so we need to look into this matter. So this is the light intensity. Similarly, for the temperature and also the distance, it projects all as well. So I think that's all from my system. Thank you.